Hello, my name is Isha Chawla, and today I will be explaining my project. Uh, this is the project which I have created. The topic for my project is automated light control system. The reason I have chosen this topic is because in the era where energy conservation and sustainability are crucial, inefficient lighting system represent a significant challenge in both residential and commercial spaces. The traditional or the manual lighting practices often results in light being left on even in the rooms where it is not required. So this led to excessive energy consumption. So these are some current industry practices. The manual controls. Most commercial buildings still rely on the manual switches and timers for lighting control. This approach requires users to remember to turn on and off their lights, which often lead to human error because in their busy schedules, the individuals may often overlook or forget to turn off the lights when it is not needed. So it contributes to the energy wastage, which results in increased the usage of cost over time. There are some static solutions also, but these solutions are designed with fixed settings that do not adjust based on the changing conditions. The basic lighting system or the manual lighting system lack the intelligence to adjust the light based on the real time occupancy and the natural availability of light. These are some challenges that are faced in the current solutions. The first challenge is energy wastage. Lights are often remain on during the daytime when natural light is sufficient. So at last the energy gets wasted. Then the lack of automation is also one of the challenge. The inability to adjust light levels based on the ambient conditions results in the lack of automation. Ambient condition here means it refers to the amount of natural light or artificial light present in an environment. The third challenge is human error. Due to manual operation, there are chances that individual may forget to switch on the light due to their busy schedules. So it again lead to the energy wastage. Then environmental impact. Increased energy consumption contributes to higher carbon footprints and environmental degradation, which leads to increased global warming. Inconvenience. The manual operation requires a constant user attention, leading to frustration and disruption, especially in their busy schedules. This slide shows the importance of embedded systems in solving this real world problem. The integration of embedded systems in the automated light control system represents numerous opportunities to enhance energy efficiency, user experience, and the overall functionality. Embedded systems basically collects data on the user energy usage and the occupancy pattern, and further this data is analyzed, which help users to make informed decisions about the lighting habits. The embedded systems can effectively solve this problem of inefficient lighting by using the real-time data from the sensors so that the users can make informed decisions. So this is the solution to the problem. Uh, uh, the project implements an automated light control system that utilizes PIR, that is passive infrared sensor, to detect occupancy. Occupancy means the occupancy means the presence of people in a specific area or in a room. Then the LDR sensor, that is light dependent resistor, to measure ambient light levels. Ambient light levels refers to the amount of natural or the artificial light present in an environment. The system will automatically adjust lighting based on real-time conditions, ensuring optimal energy use and convenience for users. These are the components that I will be using in a project: Arduino Nano 33 IoT, Raspberry Pi, PIR sensor which detects occupancy or motion, LDR sensor that determines the ambient light levels, and the LED lights. So this slide shows the working of each component individually. The Arduino Nano will serve as the primary microcontroller, which utilizes PIR sensor to detect occupancy and LDR sensor to measure ambient light levels. It processes data from the sensor, and it also helps in controlling the lights. PIR sensor, it detects the motion and occupancy in the room, triggering the light system when the presence is sensed. LDR sensor, it monitors ambient light levels to adjust the brightness of the light dynamically. Basically, LDR sensor will determine the amount of light that is already present in that specific environment or room, and according to that, it will switch on, it will increase or decrease the intensity of the light. Uh, and it also provides input to the Arduino to determine whether to adjust the brightness of the lights or not. Then the LED lights, it is controlled by the Arduino based on the sensor input. Raspberry Pi, it acts as the central processing unit. It collects data from the Arduino, and it also provides a user-friendly interface which allows the user to monitor and control the lightning system. These are the These are the main communication protocols. Communication protocols is basically it determines that how the data will be transferred and received between devices. The first one is I2C protocol. It is suitable for connecting multiple sensors to the Arduino Nano while it enabling it to communicate with Raspberry Pi. Then SPI, it can be utilized to connect high-speed sensors to the Arduino that allows quick data transfer. Then the last one is MQTT. It is ideal for IoT applications. It allows the devices to communicate with the central server, which is known as the broker. It can also be used for sending and receiving data between the Arduino and the Raspberry Pi. Then this slide shows the user interface. The It basically shows the interface that the user will be interacting upon. The user interface will be web-based. The users will be able to monitor real-time occupancy and light levels. And they can adjust the lighting settings. Example, they can turn on and off the lights, and they can even change the brightness. Then they can also receive the notifications regarding the energy usage patterns. This is the block diagram for my project. The PIR sensor and the LDR sensor, the data from both the sensors is processed by Arduino Nano, which is further transmitted to Raspberry Pi, and it is further connected to the user interface, which is web-based. Then this is the flow chart. The PIR sensor first detects the motion. If motion is detected or the presence is felt, then the LDR sensor will determine the ambient light levels. It will check that how much light is required in that room, and based upon that, it will increase or decrease the intensity of the light. If no motion is detected, then it waits for the next reading of the sensor. And if motion is detected, if there's sufficient light level in that room, then turns or it will decrease the uh, intensity of the light, and otherwise it will increase. And if there is no motion detected, then it will wait for the next reading of the sensor. And this is how the project works. Thank you.